Hello and welcome everybody to today's webinar. My name is Julie Basu and I'm here with my colleague today, Terry Gallagher. We are co-founders at SmartQED. We are a company based in the Silicon Valley. And today we're going to talk about AI-powered visual root cause analysis for higher efficiency, productivity, and reliability. Hi, Terry.
Good morning, good afternoon, good evening.
Wherever you are. And the tool that we will be talking about today that will help you achieve the efficiency, productivity, and reliability is ProSolver, which is a new product that we have launched. So without further ado, let's move on. We start the talk with a quote: identify the root cause and the solution will reveal itself. I don't know who said this. We tried to research it, but whoever did, maybe it was ChatGPT, basically, if this statement is very true and the reverse is also true. So if we do not identify the root causes for a problem, then the solution or solutions that we come up with are going to be either incorrect or incomplete. So with that as our basis, that it is extremely important to identify the root cause to prevent problem recurrence, let's jump in to the agenda. So what is root cause analysis? Goes by the shorthands of RCA or RCCA, stands for root cause and corrective actions. So what are the difficulties and inefficiencies in this process? Terry and I will be talking about the ones that we have faced and also the insights that we have gathered from the community. And then our innovative solution is to come up with a mechanism that will enable people to overcome these difficulties and inefficiencies. And we will present today this notion of smart fishbones, which actually enables you to do visual collaborative analysis as well as provides AI-powered recommendations. Then we will go over the benefits and the use cases. Just before we move on, you can follow our company at linkedin.com, company ProSolver. You can look at our website, prosolver.tech, and also register for our beta. And you can be an individual or a company. You just need to give us your email and register on the launch page. And then we can work with you to understand your use case and kind of do some basic training and guidance if it is necessary. Okay, so moving on, what is root cause analysis? This is just a very quick overview. The goals are to improve the quality and increase reliability. And there is a method to this process. It's sometimes called 5W, 1H, or 2H. It has to cover the when, why, where, what, who, and how much aspects to define the problem, right? So this whole thing kind of forms the description or view of the 360-degree view of the problem. So initially, you, of course, don't have this entire view. We start with a description of the problem. So, for example, I go to the doctor and I say, I have a headache. Right? And then the doctor starts collecting evidence. Well, you have a headache. Do you have fever as well? Right? So that is the evidence collection part, or they measure my blood pressure. Am I anxious? That's why I got the headache. So the problem definition is followed by evidence collection. And then you start the analysis, and the analysis has to be in-depth. Right, we talked about that. If we don't get to the root causes, then whatever we come up with as solutions is going to be incorrect or incomplete. So we have to identify them properly and then take containment measures and corrective actions. This is only after we identify the root cause, and then we have to also prevent problem recurrence. These are preventive actions. What can I do to not have a repeat of this problem? Right. So maybe if it's an automotive problem, we might issue a recall of the car or a repair notice. It's very common. Companies do this all the time. Recalls are made to prevent problem recurrence. And then last but not the least is learn from the experience. This part is very important because we want to assimilate the learnings. Today, we do it in our heads, we do it through knowledge articles, we communicate to others, what did we find, what did we learn, and then we kind of, it gets part of our tribal knowledge, if you will, so that it can be applied, the learnings can be applied in our design or manufacture going forward. So the critical points of RCA are, it has to be comprehensive. Yeah. And it's also typically collaborative because a single person doesn't know the entire system. So by the nature of RCA of any real system, you'll have at least 2 people working on it, most likely more bigger teams of sometimes, hundreds of people. And it's of course evidence driven. It's everything has to be based on evidence. What was found, what were the symptoms, and when were they seen, how did it unfold, right? So with that, we move on to the difficulties and inefficiencies. So the first one is, of course, complexity. Today, systems are complex and they are actually getting more and more complex. So we had cars before, now we have self-driving cars, right? So there are additional components that are pretty high tech, and the older tools that are in use today, we believe actually do not scale well, I should say. Why? Because they're linear, they're often forms-based, they are tables-based. Here you fill out a form to do your RCA. Well, it's not really conducive to a big system to fill out a form, which can get actually very large and clunky. Second one is collaboration. We already mentioned it's a collaborative effort, usually, and today's teams are by nature distributed and they're tough to coordinate. Right? If you have a big company, your support or operations or manufacturing teams might span countries and time zones, and to get everybody on the same page is not easy. Yeah, so teams can be, people can be talking at cross purposes, sometimes duplicating work or not knowing what's the big picture. So next we come to the knowledge aspects, right? So let's say I built up a super duper team, but people these days tend to move around quite often. So experts are likely to leave and their knowledge is lost. Right. So this is the churn that we face, and you can actually try to train up somebody, but that training time is sometimes in months, because when the experts leave, it's the experience of several months, maybe even years. So to train up somebody to that level is not easy. So today, people are solving these problems. How do they handle it? So they will make people, write document articles or knowledge articles or how-to guides or don't do this. These are the best practices, right? And once that knowledge is captured, and today it's captured in text, the process of learning is typically manual, right? So I would have to search for those best practices or how-to guides and then read them and apply them in the right place at the right time, right? So this is where actually in number 3 and number 4 that AI can help us a lot. In fact, if people have played with ChatGPT, this is one of the reasons that ChatGPT has made such an impact. So today, if I went to Google and did a research on, say, airbag failure, then I would be, given a set of links that I have to click and I browse maybe for a couple of hours to put that knowledge together in my head and then put my own analysis of what are the things that can cause airbag failure. Whereas if you went to ChatGPT and gave the same query to ChatGPT, hey, can you tell me what are the reasons for X, Y, or Z, whatever it is, it actually not only does the searching, it does the aggregation and then presents it in its own words, right? So the manual learning, we believe, is actually one of the biggest causes of inefficiencies. Maybe it's not obvious at the very first minute that this can take up a lot of time, but today people are absolutely spending a lot of time in manual training, manual learning, and knowledge capture as well. So with that, I'll have Terry, please weigh in. Terry, do you agree with this difficulties? Have you faced them? What are your thoughts?
Sure, absolutely. There's a couple of different viewpoints from here. One is you mentioned the complexity. Oftentimes there's multiple contributing factors or root causes that come together in sometimes the proverbial perfect storm to cause problems. Oftentimes there's, well, almost always multiple layers in the tech stack. There's so many dynamic changes with DevOps and Agile that combinations of components are just changing all the time. and you don't really know often times how that change may impact something. So yes, very complex. There's also documentation issues, trying to record relevant details after the fact is oftentimes, most of the time, really doesn't work very well. Maintaining run books and knowledge articles, a lot of work to build and maintain, oftentimes never even opened or read, or incomplete or out of date when the time comes to use them.
Yeah, so I am sure here people resonate with these issues. So they've been there all the time, it's not, but the trend is that they're getting tougher to handle, right, Terry? You agree with that, right? It's getting more and more knowledge and more difficulties in handling the root cause analysis that is complete and correct.
Certainly. More and more opportunities for error, as I like to say.
Yes. Yes. Okay. So what can we do about it, or what would we like to do about it? So our innovation is smart fishbones. People may be aware of this fishbone analysis. It's been there for many decades, actually. Fishbones are just nothing but nice compact view of a tree and subtree of potential causes. So I can take a problem like airbag failure, break it down, what are the reasons it could have failed, and then break it down further until I get to the appropriate level of detail. And the fishbones are actually just a compact view, nice use of real estate. And because of the image, it's not linear, it's laid out in a horizontal fashion. So you can absorb a lot of information at once. It was actually designed by Professor Ishikawa to do root cause analysis of Toyota cars. And as we know, Japanese cars cannot really be beat in reliability. They have, through the years, established this reputation, and that quality of, or high reliability is not accidental. They really worked hard at it through all these processes and methods. So what did we do? We took fishbones and we said, okay, can we take it to fishbone plus, the next view of it? So it's layered views, because you cannot really capture the entire system in like 2 dimensions. And once you go beyond 3 levels, it actually gets very difficult to comprehend. So we have adopted the visualization, but you can of fishbone, but you can also view it as a tree. And the important thing is that the layering of views. It's a simple enhancement, but it makes a world of difference because it gives us a handle over the complexity. Human brains can only take in so much information at a time. It's like playing chess. You can't think more than 2 levels deep. Yeah, and because of this structure, we can actually organize the data and the evidence. This is very important. It has to be evidence driven and associated with individual causes and subcauses. Most important, the organization, because it enables a systematic analysis. And we have integrated fault status tracking. You can use colors to obviously see what was a contributing factor, what was not, what was cleared, what is still being investigated, so that the collaboration is smoothened out. Yeah. So one of the biggest glitches in collaboration comes from the fact that I don't know what Terry is doing. Terry doesn't know what Ron is doing. And so we are not on the same page, right? So it either delays work or duplicates work. So the collaborative analysis really gets a boost, I would say, or it's like a level of magnitude higher. It's easier if you look at it as an image and say, okay, I know Terry has cleared this. I know Ron is working on that. Yeah, it's just the visuals make all the difference. And last but not the least, these maps can be templatized and they can give you a jump start over the RCA process. So if I've already analyzed airbag failures, or I know how to go about airbag failure, or for that matter, a build failure or an aircraft failure, whatever it is, I can templatize that work in the proper module for the proper module. Yeah, so I cannot really say that templatize the entire car. Maybe the throttle has a certain design and a team associated with it. They can come up with their template, and the pedals have a different another team, and they can come up with their templates. And depending on the problem you're solving, you can pull in the appropriate templates. So we call this mix and match templates that are very powerful. Every component can have its own template, and then as you're analyzing the problem, you pull in the right components with their templates. So this gives a big jump start. Now we come to the interesting part for AI-powered insights. How can AI help us? We already said knowledge management, knowledge analysis is moving more from manual to automated. That's a fact. The fact that ChatGPT got downloaded like 100 million times or something is a verification for that. Google searches and let me search my knowledge base and read what was there before, what was seen before is getting to be outdated. Why? Because like Terry mentioned, systems are very complex. They have multiple versions. It's very difficult to identify the proper nuggets through your knowledge base. So solved issues in our case go in the RCA vault. It's really a knowledge vault. It has all your solved problems with the data. So I saw airbag failure, and maybe it was from the bad glue, and I'm going to upgrade the glue or get a new supplier, whatever it was, right? So these issues go into the vault. It has problem cases that have been resolved, and the AI can actually interpret these visual maps and the associated data. So the more information you put in, right, the AI does a better job. So I don't want to minimize that aspect. ChatGPT got so good because it was trained and trained and trained and trained and trained. Yes, so that's why it's gotten so good. So the AI is only as good as the data and the training that it has. So in our case, it actually learns from the data. So the training, as you are updating this Fishbones, it feeds into the AI engine. So when you're putting the data in, it's not just for documentation. Think of it that it's also a form of supervised training, because the AI engine is going to learn from the data, right? So it can interpret the visual maps, and then later it can use that data to do symptom-driven matching. So as an example, I can say, I have headache. Well, if I go to the doctor, he or she doesn't give me Imodium. He says, oh, maybe you take Tylenol, or maybe you are stressed, you do this. They do not give me stomach medicines because in their mind, they know the association. The headaches do not relate to digestive issues typically. It might, if I have diarrhea, it might. So it's the process has to be, kind of step by step. Multiple causes, and you have to identify multiple causes. If there are, maybe I have diarrhea, which gave me headache because I am not able to eat. So it's symptom driven. The AI, you enter the symptoms and you get the recommendations, and they're aggregated. This is very important. I think that is one of the critical benefits of something like ChatGPT, that I don't need to read 100 Google links. ChatGPT is going to summarize, give me a gist, which makes it that much easier to absorb and assimilate. Template suggestions are included as well. We are doing some exploring some integration with ChatGPT. That is going to remain a mystery at this time, and we will have more information as we go forward. Last but not the least, we have also automated reporting. So one of the ways automation can help us is to remove the tedious work from being done by human beings. So once you put the data into the structured format, it's actually very easy to generate a report, because I can actually select, customize it, say, hey, don't include the attachments, but include the notes and include the actions, because those are the important pieces that I want to communicate to my customers. And you can pick and choose what you want to include. And after that, it's either a one-click manual download of the report, or you can even set it up to be automated emails that are sent out, periodically, say 15 minutes or every half an hour or one day, whatever it is, based on the problem priority. Now, the reports can come in multiple formats, could be summary or detailed reports in PDF. And we have recently also added support for AT reports in Excel format, because AT is a standard in different industries like manufacturing, automotive, and possibly others. And like I mentioned, these reports are very easily generatable. Once you put in the data, multiple things happen. They enable you to get on the same page, right? Generate reports very quickly, and also train up the AI that's behind trying to learn, oh, they saw this and they did that. Terry, do you want to add some quick thoughts?
Yeah, originally kind of was a little IT centric in my last explanation, but obviously root cause analysis can be done in manufacturing arena, healthcare arena, in particular bill of materials, different components, different manufacturers at different points in time can really be difficult to kind of ingest and understand. This tool has the capability to, if you give it enough data, to identify like common failure points for particular components or products. And in healthcare, obviously there's lots of different combination of symptoms and so forth, can help identify more common
right,
illnesses, et cetera, based on symptoms that you give it.
Yes. So this webinar does not have time for a full demo, but I wanted to give you a quick preview. This is a screen capture from our tool. So we are analyzing here airbag failure. And like Terry mentioned, we have a prior product called Smart QED that was oriented towards IT incident management. Now we have learned from that experience and broadening the footprint of our product and the capabilities to address RCA in different domains. And RCA is domain independent. It's required for any kind of problem analysis, be it healthcare, maintenance, manufacturing, doesn't matter. Root cause analysis is universal almost in any kind of business. So here we have taken an example, airbag failed. Why did it fail? This is the 5M1E method, machine method measurements, materials, and a man or environment, and maybe it was bad glue that, and you can do further analysis. Why was the glue bad? It doesn't have to stop here. Maybe my supplier wasn't good, or I bought cheap glue, so I need to upgrade the glue. So there is a further level possible. And so that is enabled through the layered views. So I can easily decompose at any level and go down as much as I want. This is the entire tree of possibilities for an airbag failure. It could be lack of maintenance. It could be wrong installation. It could be even damaged spring, even be the airbag got wet because there was some, flood damage or something, water damage to the car. So multiple causes, all of them have to be eliminated. And like I mentioned, you can templatize this so people don't have to be trained up. Oh, what are the possible causes? Let me sit and read a knowledge article, right? These templates are actionable. You pull them in and jump into your RCA. So now a quick view also of the AI. Next, if I have another incident of airbag fails, then can I invoke my engine? The answer is absolutely yes. And what does it do? It can go through my vault of solved problems and templates also and find everything that matches by symptoms, completely symptom driven, and it's has some natural language capabilities. So for example, if I say airbag failure, versus failed airbag or failing airbag or airbag did not work. So it has some smarts based on the AI NLP functionality, natural language processing, say, okay, these are just similar. So for example, I have a pain in my head is probably the same as I have a headache. So it's has some smarts. I'm not saying it's perfect as a human, but it does have the capability to interpret in a fuzzy way and do a fuzzy matching. It's a weighted matching of symptoms, and the problem that is seen, even the description is taken into account. What are the nuggets in the description that match my nuggets in the earlier problems? And then it summarizes aggregate, that's most important, finds the matching problems, then that's the aggregation step, which is, in this case, just a sample. 50% of the time it was materials, bad glue, incorrect part, whatever, and other times it was a faulty sensor, some malfunction, something defective, etc. So this is how it can help you. And again, this template, the aggregate template, is actionable. So I can say, okay, I like this template, let's go and run with this. Right. So the benefits of our solution, I am sure you see the possibilities already. It's easily scalable to complex problems. Because like we said, capturing all this Even a simple thing, airbag failure is a fairly simple problem. It has 25 or so causes. Yeah, so to cover them in an Excel sheet, it's very easy to get lost because all these sheets and tables and linear charts, they are linear. Okay, so human beings actually absorb pictures much better, images much better than reading linearly. And then in the background, we are actually trying to form the picture in our heads, but that picture is not there on the paper or on the screen. So it makes it that much harder to handle complex issues. And large teams all have to be on the same page. Automated reporting and knowledge capture. So this is training as you work. You put in the data, and it's also training the AI to do a good suggestion next time you ask, hey, what are the causes of this failure? Right? It can also slash tedious work on the reporting front and training times. This is very important. The knowledge is captured in the system, right? If my expert leaves today, I don't have to tear my hair out, assuming he or she has done a good job of putting the knowledge, problem-solving knowledge in this system, in this tool, then it's there. It's actually there forever. The machine does not forget, which is one of the best advantages. So as a result, you'll get higher efficiency of the RCA process, you'll get higher productivity of teams, quality and reliability are a little more longer term, but you'll definitely see this benefits, and that of course results in happier customers. Now, what are the use cases? We already talked about these. I will share the slides, by the way, in the I'll share the recording on LinkedIn. So there are many domains where these techniques are used. People that have done Six Sigma, Lean Six Sigma, and ITIL, that's IT specific, but many places root cause analysis is emphasized. You can find applications in automotive and aerospace, aircraft incidents, auto incidents, cause analysis, corrective and preventive actions. It goes by the name CAPA. So we have built-in support for recording corrective and preventive actions in our tool so that you can track them also easily. Healthcare, medical devices such as pacemakers and ventilators, these are critical instruments, or MRI machines. They have to go through a rigorous quality analysis during manufacture, in deployment, at hospitals, if there's any kind of adverse situation. And oftentimes these RCAs are required for compliance. If a ventilator malfunctions on a patient, then definitely it's a compliance issue and a regulatory issue. Yeah. So IT security, we already mentioned that software is pretty complex, cross-functional, it's on the cloud, it could be a hacker, it could be this, it could be that. What is it? So distributed teams, it's essential for business success. An IT crash can actually kill a business, or a security breach can actually completely destroy business credibility. So root cause analysis is very, very important for these this domain. Maintenance and manufacturing goes without saying. This is the core where it actually evolves. Fishbones were originally suggested for Toyota cars. That's the original place, but because cars have to be reliable, they cannot die on us suddenly while we are driving. So manufacturing and maintenance is definitely very important to not only find the causes, but also prevent the recurrence. So we end with a kind of a little testimonial. There is an urgent need of such a visual tool in the area of problem solving, knowledge analysis, and incident management. This innovative tool serves a greater purpose. This quote is from Fanienda Somraj. He's a process improvement expert. He tried our tool hands-on. He's a Lean Six Sigma Master Black Belt, and we are in absolute agreement with his assessment. What do you say, Terry?
I too am in agreement. Yes, it's
Yes,
nice. It's nice to have a tool that can aggregate data and point you in the right direction right out of the gate.
yes.
Oftentimes you waste a lot of time just trying to narrow things down.
Right. So I think with that, we kind of wrap up the webinar. Sorry, we've gone over by a couple minutes. You can contact us at info@prosolver.tech. Please follow us on LinkedIn, company/prosolver, and we will post the recording as well. And okay, here's another quote. Thank you for your time and for attending. So success lies not in finding quick fixes for symptoms, but in uncovering the true causes and addressing them with corrective action. I think we can all agree with this. And in fact, Ron gets the last word. Ron, did you say that this is ChatGPT that came up with this quote?
Yes, it was ChatGPT.
Yeah. So it got to the heart of the matter. We don't want quick fixes, but actually get to the bottom of issues and fixing them once and for all to avoid recurrence. Okay, so with that, I'm going to open it up. Anybody that wants to talk to Terry or me, thank you for joining again. Please go ahead, ask your questions.